So 11.9 is power series representation, and the formula we will be using is for a series like this equals 1 over 1 minus x when absolute value of x is less than 1. So a geometric series like this equals 1 over 1 minus x when the absolute value of x is less than 1. Let's do some problems. We have to find a power series representation for the function and determine the interval of convergence. So always we will compare the given, we will try to rewrite given function in this. If you observe, this is just factor out a 3. Now we can use this formula, replace x by x over 3. With so this means f of x equals 2 or the interval of convergence is negative 3 to 3. So this is a simple problem, a basic example. It's like when you multiply 3 to here, this becomes 3 to the n plus 1. But both are correct. You can leave it in any form. Okay, let's do next problem. Number 9. So note that the power of x is same in numerator and denominator. Same. So we can rewrite this so I can add and subtract 3. Why 3? Because I want 2. Try to make numerator same as the denominator. That's why we add and subtract 3. Means f of x becomes 3 minus 1 is 2, and now we just split it. So which is 1 minus 3 over x plus 2. It is 1 minus 3 over 2 minus x. Or so we always have to write it in this form, 1 over 1 minus something involving x. So this comes as we factor out a 2. We have 1 minus, and this is the series. You can bring out a negative here separately. We can improve it further if you write, okay, what is n equals 0 term? Because we have a constant here, 1, and n equals 0 is also constant, so we can add or subtract the constant. So n equals 0 term is just 3 over 2. We can rewrite 1 minus 3 over 2 minus, now the sum will start from n equals 1. 3 over 2 minus. So we have written down n equals 0 terms separately here because we can now add it with constant. So then the final answer becomes minus half this is the series, and if you note, this implies that mod of x minus 2 is less than 1 or x is less than 2. So the interval of convergence is minus 2 to 2. So this problem was slightly tricky. Let's go to next problem. So we have to write a power series representation of the function and determine the radius of convergence. So f of x is given to us. Yes. Now how should we begin? If you observe, f derivative x is 1 over 5 minus x times negative 1 because of the chain rule. So it means f of x is the integral of negative dx over 5 minus x. Now let's write down what this series is. 1 over 5 minus x equal to, if we factor out 5, same thing that we have been doing. So now we substitute the series over here. Negative integration of now if we write it term by term, we get 1 over 5 x over 5 square x square over 5 cube x cube over 5 fourth, so on. So do not integrate directly. Always write first few terms and then do the antiderivation. So the antiderivative becomes negative x over 5, and derivative 1 over 5 is x over 5 plus x square over 2 times 5 square plus x cube over 3 5 4 plus x4 4 5 5, so on, plus a constant of integration. Now we can find this constant first. So note that f of 0 is 0 plus c, which is ln of 5 minus 0. This means c is ln of 5. So in order to determine the constant c, just substitute x as 0. Then all this goes away. And we're left with c. And substitute x as 0 in the given function. ln of 5. So now we can rewrite f of x as ln of 5 minus this whole thing. So it is, if x is n, you have n here and you have n plus 1 here. So first thing to know, there is no other constant term. So n will start from 1 because the first term is x. So when x goes to n also is written here, and 5 goes to n plus 1. So that's your answer. Let's see, let's do another problem. Number 19. So observe, this is 1 plus x times 1 over 1 minus x squared. Let's first focus on this part. So if you note, one over 1 minus x square is d by dx of 1 over 1 minus x. Well, it's not made. So it's d by dx of 1 over 1 minus x. So we know 1 over 1 minus x is means 1 over 1 minus x square is d by dx of 1 plus x square plus x cube, so on. So we get the first term is 0. You get 1 plus 2x plus 3x square plus 4x cube and so on. Now x times 1 minus x over 1 minus x squared becomes, because we're interested in 1 plus x. So let's first write what is x times x squared. It's x plus 2x squared plus 3x cube plus 4x4. So now 1 plus x minus x squared is plus so 1 so this is, so I'm adding these two. So 1 plus x times 1 over 1 minus x squared is sum of this and this. So adding these two, adding this and this, gives us 1 plus x over 1 minus x. So now what we get, if we add, we get 1 plus 3x plus 5x squared plus 7x cube plus 9x4. So this is same as 2n plus 1 times xn. We start with n equals 0 because the first term is 1. When n is 1, you get 3x. N is 2, you get 5x squared. N is 3, you get 7x cubed, and so on. So this is an important problem. Now the next problem is 25. Evaluate the indefinite integral as a power series. What is the radius of convergence? Just for the previous problem. The radius of convergence here is, see, this series gives us R as 1 because mod of x is less than 1 over here. And similarly over here, get mod of x over 5 less than 1. So mod of x is less than 5. So let's first start with 1 over 1 minus t to the 8. So this is same as mod of t less than 1. So this gives us R to be 1, radius of convergence. But we need this form. So t over plus 1. So now if we integrate it, first note that since radius of convergence is 1 for the series for t1 is t8, therefore R is 1 for the integral as well. So R will always be 1 for this. Now we can do the integration and write and this is easy to see. plus an integration constant. And this is nothing but same what we get over here. So if we integrate this power, we will have t8n plus 2 over 8n plus 2 plus c. So this was an easy problem, but good problem. Let's do one more problem. 27. Now we start with, first note that, note ln of 1 plus x is the integration of so now 1 over 1 plus x same as 1 minus x. It is with root of x less than 1. So ln of 1 plus x becomes integration of minus x plus x square minus x cube right. So ln of 1 plus x integral of this, and this is term by term. If we do the integration, we get x minus x square over 2 plus x cube over 3 minus x4 over 4 x5 over 5 minus so on plus some integration constant. Now we can find c by substituting x equals 0, since at x equals 0, ln of 1 plus x equals ln 1 to c, which is equal to 0. So when x goes to 0, you get ln 1. This whole thing goes to 0, only c. So c is 0. So now if you observe, ln 1 plus x becomes this quantity, which is summation n equals 1, because it starts from x. But the first term is positive, first term is plus x. So if n starts from 1, x is n over n minus 1. Because n equals 1 is x. So when n is 1, you get 1 here, x. N equals 2 is negative x squared over 2. So when n is 2, you get negative 1, x squared over 2, and so on. And for x squared times ln 1 plus x becomes, so we need x squared. So therefore let's see. Now the same thing, because radius of convergence is 1. Since r equal to is 1 for the series therefore r is 1 for the integral as well. So that's the final answer. So first we recognize that ln x is the integral of this quantity. We write power series for this. Do the integration. Find c. Get the series for ln 1 plus x. Multiply by x squared. The series for this term. Then do the integration. With n plus 2, so n plus 2 plus 1 is n plus 3, divided by n plus 3 plus c. Because r is 1 for this series and for this one also.